All right. Hope everyone's enjoying their 3-day weekend. And today we are going to be learning about our next topic dealing with exponents. And this is on multiplying and dividing monomials. Now, you're probably wondering, what is a monomial? Well, let's define that first before we get into anything else. A monomial is a number. It is a variable, or it is a product of numbers and or variables. So again, a monomial is a number, a variable, or it's the product of numbers and or variables. Let's take a look for a second at what could be a monomial and what's not a monomial. So let's make two columns here. We're going to do monomials and not monomials. Now, for a second, if you actually look at the word monomials, you'll see it starts with mono. Mono being one. Nomial comes from the word term. So a monomial is actually one term. If you remember from the beginning of the year, we talked about terms when we were talking about distributive property and things like that, where you could combine like terms together. A monomial was one of those terms. So something like a number like 8 would be a monomial. A variable like m would be a monomial. 8m would be a monomial. 7x squared y cubed is a monomial because all it involves is a product. But let's take a look at something that's not a monomial. Something like x plus 4. That's not a monomial. Now, it's the sum of two monomials, and that's okay, but that's not a monomial. We actually call this a binomial because there's two monomials being added together. But we're not worried about that. We're more concentrating on monomials right now. X squared minus y squared. Again, not a monomial. Or how about this? X squared over 5. That again, not a monomial because it's got division in it. So now what we're going to do is we're going to talk about how we multiply and divide monomials together. Now I want you to consider, before we really get into it, I want you to consider this problem. Take consideration something like 2 to the 4th times 2 to the 3rd power. And think about what those actually mean. 2 to the 4th times 2 to the 3rd. And if you think about what the meaning of that is, let's start with 2 to the 4th. 2 to the 4th actually means 2 times 2 times 2 times 2. Now, I want to multiply that times 2 cubed, which is 2 times 2 times 2. So if you look at this as one giant problem, I have 2 times 2 times 2 times 2 times 2 times 2 times 2, which really is one just multiplying 2 together by itself 7 times. So what I really have here is 2 to the 7th. Now, some of you are probably screaming at the screen already, I know how I could have done that easier. Well, yeah, you're right. There's a lot of ways I could have done it easier. Matter of fact, you probably are going, why couldn't I just have added the exponents together? Because if I take 2 and add 4 plus 3 together, I also get 2 to the 7th. And that's absolutely correct. So that actually brings us to our first property, and that is called, there we go, the product of powers property. The product of powers property. And what that says is it says if I have any exponent, any power I should say, multiplied to another power, then all I have to do is add the exponents. Now, one thing I want you to be very aware of and notice, a to the m times a to the n. What that says is that the base, when you're using this property, the base absolutely positively must stay the same, and it doesn't change at the end. If you went back to our problem before, where it was 2 to the 4th times 2 to the 3rd, it stayed as a 2 on the base to the 7th power. It didn't become 4 to the 7th power. No, the base stays the same. It doesn't change. So if I gave you the example, another example of 4 to the 3rd times 4 to the 5th, then what you actually get is 4 to the 3 plus 5, which is 4 to the 8th. And as long as the base is the same, you can add the exponents. Let's take a look at some more problems. Why don't you do the following for me? 5 to the 5th times 5 to the 9th. 6 times 6 cubed. 8 to the negative 3rd times 8 to the negative 7th. And finally, let's do, no, let's not do that one. Let's back up for a second. Let's do x to the 8th times x to the 23rd. Okay, so pause the recording and see what you come up with your answers. All right, so if you've done this correctly, you would have started with this 5 to the 5th times 5 to the 9th. You would have done 5 plus 9, and that would have given you 5 to the 14th power. Now, here's an interesting one, because you're probably looking at this one going 6 times 6 to the 3rd and wondering, how do I add exponents if they don't exist? Well, that 6 actually has an exponent on it. Remember, when it's just a number, it's got an exponent of 1. So that's really 6 to the 1st times 6 to the 3rd. That's 6 to the 1st times 6 to the 3rd. So that's 6 to the 1 plus 3, which is actually 6 to the 4th. Now, many of you on this next one probably said, oh, well, that's 8 to the negative 3 plus negative 7. Good. And then you probably, let's write that down, negative 3 plus negative 7. And you probably said, oh, that's 8 to the negative 10th. And I'm going to tell you, great, you're wrong. Sorry. It's not. It's actually should be, yes, that's right, 1 over 8 to the 10th, because you're not allowed to have negative exponents. Finally, on this last one, we have x to the 8th plus 23, which is x to the 31st. Hopefully you got all 4 of those correct. Now, again, remember that when you are doing this, it is extremely important that you have the same base. So if I had something like 3 to the 5th times 4 to the 6th, and I asked you what that equaled, well, you would come right back at me and say, oh, that's just 3 to the 5th times 4 to the 6th. It doesn't equal anything else. It's exactly that, because they don't have the same base. Now, How does that work when we have monomials that are a little more complex? Let's take a look at a more complex monomial. Let's say, for instance, I have 2x cubed times 8x to the fourth. Now, here, I'm going to say to you a little saying right now. Numbers are numbers, powers are powers, and you treat them differently. Say it with me. Numbers are numbers, powers are powers, and you treat them differently. Now look around the house and make sure no one was listening to you, because they're probably wondering why you're talking to the computer screen. Sorry, had to do it. But when I say that, if it's a number, and I'm not talking about a power, 2 and 8, those are just numbers. 2 and 8, why are they numbers? Because their exponent is 1. They don't have any other exponent. So I can take and I could actually multiply the 2 and the 8 together. Then I can take the x cubed and the x to the fourth, and I can multiply those together. Well, when you multiply 2 and 8 together, you get 16. And if I multiply x cubed times x to the fourth together, yep, I get x to the seventh. So take a look at this problem, and we're going to work through this one together, and then I'll give you a few to do. Negative 3 n to the negative ninth times 2n to the eighth. Now, when you do this again, I can multiply, and I underline instead of doing all the parentheses work. The underlining is the exact same thing, and is showing your work, by the way. So if I multiply a negative 3 and a 2 together, I get negative 6. When I multiply n to the negative ninth times n to the eighth together, I get n to the negative first. Oh, there's our negative exponent. I'm not allowed to have that. So I'm going to turn this into a fraction. But what do I move? Do I move the negative 6? No, that's a negative number. That does not have a negative exponent. So the negative 6 stays exactly where it is. The n to the negative first becomes 1 over n, which means it's going to go into the denominator, and I get negative 6 over n. And if you forget the little trick, remember I could always draw my fraction bar here, circle the negative exponents, and move it to the other side of the fraction bar to make it a positive exponent. So let me give you a few to try here, and let's see how well you do with these. Let's do 5a squared times 3a to the fourth. And how about 6b to the negative fifth times 2b squared? And how about we do 4x squared y times 8x cubed y to the fifth. Okay, pause the recording and try these on your own. All right, let's see if we get the same answers here. 5a squared times 3a to the fourth. 5 times 3, well, that's 15. A squared times a to the fourth, that's a to the sixth. How many of you got that right? Oh, made you raise your hand. But yes, it's 15a to the sixth. All right, here we go. 6b to the negative fifth and 2b squared. 6 and 2 is 12. B to the negative fifth times b squared. Well, that's b to the negative third. Oh, negative exponent. I think what I'll do is I'll make my fraction bar. I'll circle the power that's negative. Move it down below, which gives me 12 over b cubed. Finally, this one, I'm looking for common bases or just numbers. Remember, numbers are numbers, so I can multiply those together. 4 times 8 is 32. X squared times x cubed, well, that's x to the 5th. And y times y to the 5th, well, that's y to the 6th. So hopefully you got those three right, and you understand about multiplying monomials. Next, we're going to talk about dividing monomials. Dividing monomials, when I talk about that, I'm talking about when we might have something like 7 to the 5th power over 7 squared. No, you don't have to evaluate this out and then do the division on a calculator. We don't want those calculators. We're going to make this real easy on ourselves. If I do what I did before, like I did multiplication, I'm going to explain what each one of these powers means. 7 to the 5th, well, that's just 7 times 7 times 7 times 7 times 7 over 7 times 7. Now, a long time ago, I told you how much I love dealing with prime factorization. Well, here's why. This is literally prime factored out. So now all I have to do is cancel out common factors. A 7 and a 7. Well, everything disappears in the denominator, so what's left is just 7 to the 3rd power, technically over 1, but we don't care about that. So we leave it as 7 to the 3rd power. Yeah, I know, you all figured it out already. It is that simple. All I had to do from 7 to the 5th divided by 7 squared, yes, all I had to do was go 7 to the 5 minus 2, and yes, that would have given me 7 to the 3rd power. So with that being said, let's look at what's called the quotient of powers property. The quotient of powers property. And this says if I have a to the m over a to the n, then all I have to do is subtract the top exponent minus the bottom exponent. As long as, and I shouldn't be saying if, let's erase the if, it should be where a does not equal 0. And we have to put that in because we don't want it to be dividing by 0. And if a is 0, then technically you're dividing by 0. Interestingly enough, with this here, a lot of you always wondered, why is, any number to the 0 equal to 1? So think about this. If I gave you, say, let's just say, take a simple one, 2 to the 3rd over 2 to the 3rd. If I use my new rule, I would do 2 to the 3 minus 3, which gives me 2 to the 0 power. If I did this, I would have 2 times 2 times 2 over 2 times 2 times 2. Well, don't all those 2's cancel out, leave me with 1? Hence, 2 to the 0 has to equal 1. Ah, kind of interesting on that, huh? So, let's take a look and let me give you a few questions to try, and we'll see how you do with these. So why don't you do 3 to the 9th over 3 squared, b to the 7th over b to the 6th, 4 to the 5th over 4 to the negative 2nd, and x to the 3rd over x to the 8th. Stop the recording and try those 4 problems. Okay, let's see how you did. If you did this right, you would have gone 3 to the 9 minus 2, and you would have gotten 3 to the 7th power. Here, you would have done b to the 7 minus 6, which would be to the first or just b. Aha, let's see if you're really paying attention. 4 to the 5th over 4 to the negative 2nd is 4 to the 5 minus negative 2, which is really 5 plus 2, so this should have been 4 to the 7th. Did you get that one right? I thought you did. Here, when I do this one, I'll do 3 minus 8, but that gives me negative 5, and of course we know no negative exponents, so it should be 1 over x to the 5th. Hopefully you were able to get that one correct as well. So now, the one thing I do want you to notice about that also, notice that when it was numbers, we didn't divide the numbers. The bases stayed the same. Nothing changed. But take a look at something like this. What if I gave you two monomials, like 24 x to the 5th, y to the 7th, over 8 x squared, y squared. In this problem, again, we treat things the same way. 24 and 8, those are numbers. Can I divide those two numbers? Of course I can. 24 divided by 8 is? Yes, that's right, it is 3. I look at my x's. They've got the common base. Subtract the exponents. 5 minus 2 is 3. So it's x cubed. And y to the 7th over y squared. Yep, that is y to the 5th. So simply done like that. So that is how we multiply and divide monomials. On Tuesday, we'll take this and we'll do some work with this and see how well you truly understand multiplying and dividing monomials. See you then.